about it. All right, now, why am I dressed like a cool guy? That's what you want to know, right? Well, today is the first day of Red Ribbon Week, and it's sports day. So you know I'm about to represent all 4 sports. You know, hey, we represent the Dallas Stars, hockey, you know, Texas Rangers, baseball, and, you know, playoff shirt. You know what I'm saying? All right, what else? Cowboys, you know, we always rocking them boys, right? Mavericks. Hey, check it out. I got the shorts. Anyone like the Spurs? All right. All right. Hey, headphones. Now, we're going to do this together, so everyone pay attention. Look, Rangers won. Deal with it. All right? That's what we do. Even though we lost 3 in a row, hey, or 2 in a row, whatever. Now, tonight's the last game of the series, so if you want to watch it, it's tonight. I'm playing with the headphones out here, please. Now, real quick, you on the way in, did you grab that little half sheet of paper? Hopefully. It looks like this. Let me show you. Okay, I do not ever give out extra credit. So if I do, it's because I think it's important. Okay, Red Ribbon Week is more than just dress silly for 5 days. Ha 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 ha. Okay, it has to do with living a drug-free lifestyle because people destroy themselves in their youth with drugs, which is like very sad. So I want to encourage you to not be that way, right? So I will even offer you points in my class. That's how much I want to encourage you, okay? So listen, if you make a poster, listen. If you make a poster, I want to hear nothing. Thank you. So if you create a poster that supports a drug-free lifestyle, this Friday is when it's due, okay? I am not giving you class time. This is not an assignment. It's extra, and it's extra if you finish all my assignments. It's like icing on the cake. You got to make the cake first, and then you put the icing on. So again, this is something you would do at home on your own time. Make it awesome. Turn it in by Friday. I know y'all can read, and I know you can count to 4. You have to do all of this. So some of us only do 1 and 2, and that's not it. Okay. So you need a poster, like a, you know, and you need to make something that's colorful. Don't just put drugs bad in black on white. That's not interesting. Duh. Okay. But make it colorful, interesting, unique. Okay. I know it's Halloween time, but it doesn't have to be graphic and gory. I mean, I'm not giving you ideas. I'm telling you, do not do anything that's school inappropriate. But this is important. I can give you math points for math work. So when you draw a picture, that's not math work. So here's the important part. I'm asking you to do a simple search for a simple statistic. I'm not even asking you to do any computation. Just find a statistic, throw it on the poster, and tell me the website. If you don't do these 2 things, you don't deserve credit because you didn't read and do what I told you to do, okay? So again, this can be interesting, fun, informative, helpful, and of course I like to put them on the wall and say, that's cool, all right? So that's, again, this is optional. Do not do this before you do the assignments. Your assignments count way more than the extra credit will help you. I'm telling you. This is if you're done with my work or when you have free time at home. This week only. Cool. All right. Now, that being said, we're going to do this warm-up, and then we're going to do some notes. This could be kind of a long note, or it can be shorter, depending on how much you respond when I ask you questions. So please participate, and let's get this done fast so you have some time to work at the end, okay? That's the plan. Don't sneak in your headphones when I see it. I'm not blind. All right, here we go. This warm-up says to find x. Now, we have a triangle, and inside of this triangle, what do these 3 angles add up to? 180, thank you so much. Does everyone know that? A triangle adds up to 180? Oh. Okay. It's okay, I'm hurt. Now, inside of a triangle adds up to 180 degrees. So let's go ahead and make a long equation. You're going to add up all 3 angles. Hey, don't do that. So let's write it out. 13x plus 2 plus the other angle. Let's try this again. 13x plus 2 plus 5x minus 7 plus 3x minus 4. Those three angles inside of a triangle always add up to 180. We've done one like this on the notes. So reminder, this is how you do it. How do I make that long equation simpler? What do I do? What do I do with those terms? Combine like terms, right? Anything that's the same on the same side, combine it. 13x, 5x, and 3x can combine to make 21x. And then your constants, 2, -7, -4, gives you -9. Bring down equals 180. And now it's a two-step equation. Could you solve this? You want to get rid of the loner, the -9. What's the opposite of -9? +9, +9. So 21x equals 189. And then to get rid of this 21 in front of x, we divide, okay? Make sure you're writing this down. So 189 divided by 21 is, get this down, should give you 9, okay? And you could plug it back in to get the missing angles, possibly, okay? Now again, stick with me because we're going to do some notes. We're not going to do all of them. We're going to just do part of it. Okay? We get through this quicker, the more y'all participate. Yeah. Oh, the hearings. Stars, Rangers, Cowboys, Mavericks. Yeah. Number 1. America's team. America beats. Right? That's what America's team. All right, here we go. We're doing the notes. Stay with me. Captain America's team. All right, y'all remember what isosceles triangles are? What are they? How many sides are equal? Isosceles is 2 equal sides, right? Okay, now, when you have those 2 equal sides, they're called legs. Underline that. So in this picture, hey, what are the names of these legs? So this leg right here is from A to B. So I have leg AB. And on the other side, what's the other leg? BC or CB. Okay. So AB is congruent to BC. Again, I know those are legs because they are congruent. They have little tick marks on them, okay? Second part, where those legs meet is called the vertex. What is that vertex angle at the top called? Angle B, yeah, so let's write that down, angle B. So does everyone see? 2 equal sides are legs, where they meet is the vertex, and then across from that vertex at the bottom is called the base. So what's the name of this base segment? AC. And then last but not least, on that base are the other 2 angles. Those are called base angles. What are those base angles called? So these bottom 2 angles are called what? What's this one? angle 2 or angle A, and then the other side is angle C. Cool. All right. Now, here's what we know. Isosceles triangles are two equal sides. If two sides are congruent, then the angles that are opposite are also congruent. I want you to imagine this. Look. Look, look, look. Everyone look. If you have two equal sides, the angles across have to be equal. So two equal sides, two equal angles. Kind of makes sense, right? It matches. So here's the way you would write this, okay? If AB is congruent to BC, then angle A is congruent to angle C. Can you write that down, please? If you got two congruent sides, then you get two congruent base angles, okay? And y'all remember what converse means? What did we do when we did converses? We switched them, right? So we're going to take that statement and basically just flip it around, right? That's what a converse is. So originally it said two sides gives you two angles, and now we're saying two angles gives you two sides, okay? Basically it works both ways. If you got two of something, it'll give you two of something else. So if angle A is congruent, oh my gosh, let's try that again. If angle A is congruent to angle C, then AB is congruent to BC. Cool. Now, that's the notesy part of this first section. Now notice, there's a lot of examples on here. We're going to do some, not all. Number one, y'all ready? On number one, do you see that I have two equal sides, right? That means the angles across from it are equal. So check it out. Equal sides, these should be equal, the base angles. Okay, so equal sides, equal angles. So what is J going to be? 68. Does everyone see how this works? Equal sides, equal angles. So J is 68. But K is not 68. How do I figure out K if I know two angles? What do they always add up to? 180. So once again, you're going to add up the two you know. 68 plus 68. 136. Subtract that from 180. And I get 44 degrees. Okay, so again, two are equal, the opposites are equal. If you know one, you know the other. But number two, I have two equal sides again. So which angles are going to match? What do you think? Whatever's across. So across from DE is C. Across from CD is E. So C and E, you can put a little arc at C and E. Now this one's kind of different. This one I know the vertex angle is 106. Any ideas how I can figure out these missing angles? What do y'all think? Subtract what from what? 180 minus what? Okay, so 180 minus 106, that's one step we need to do. 180 minus 106 is 74. So is 74 each angle, or? Because check it out, both of those angles have to add up to 74, right? And I know they're equal, so what should I do to 74 to find each angle? Divide by 2. Very good. Because half of 74 dividing by 2 gives you each congruent angle. So 74 divided by 2 is 37. And that's what I was looking for, C and E. So 37, 37. Cool. All right, let's try number 3. Do you see on number 3 that I have congruent angles? 77 degrees, 77 degrees. Arc, arc, okay? Now, if I have 2 equal angles, that means I have across 2 equal sides. So that means XY and YZ, put tick marks there. Those are supposed to be the same if you got 2 equal base angles. So what can I figure out here? So YZ, what do you think YZ is? YZ is a side, like over here. Okay, everyone look right here. Look, please. If I have 2 equal angles, that gives me 2 equal sides. If this is 12, what's YZ going to be right here? 12, okay? Again, matching angles gives you matching sides. So you can write 12 right here. So this has to be 12. Cool. Again, make sure you're looking up here. I don't want you on your phones. In the back, please. So, to figure out why, if I know 2 angles are 77, once again, I know they add up to 180, okay? So let's add 77 plus 77. That gives me 154. And 180 minus 154 is 26. Okay. So that's 1 through 3. We're going to do 4 and 6. You can scratch out 5 and 7. All right. So number 4. On number 4, do you see I have 2 equal sides? Once again, that means 2 equal angles. So what should I do with these 2 values? I know those base angles are equal, so I'm going to set them equal, right? All right. Good. Now, let's write that equation. First of all, put arcs here. Arc, arc. 5x plus 9 equals 8x minus 30. Y'all know how to solve that by now? X is on both sides. Do I combine them or get rid of one x? Get rid of one x, the smaller x. So minus 5x, minus 5x. 9 equals 3x minus 30. Then I need to get rid of the loner on the side of x. To get rid of that minus 30, what do I do? All right, add 30 to both sides. So 30 plus 9 is 39 equals 3x. And then to get rid of that 3, we divide by 3. 39 divided by 3 is 13. Again, scratch 5 and 7. All right, and now look at number 6. Now 6 is a little bit different, little bit. 4 had 2 equal sides. Now we have 2 equal angles. But it's just the converse. If we know the angles are equal, right? Hey, then we know that the sides are equal. So go ahead and put little tick marks there. And then, real quick, I'm about to do the harder stuff, so if you can wait till the end. Again, equal sides, set them equal, just like number 4. Okay, 15x plus 7 equals 23x minus 17. Same exact steps. Get rid of the smaller x, get rid of the loner, and divide. The smaller x is 15, so minus 15x. 7 equals 8x minus 17. Get rid of the loner minus 17. So plus 17, plus 17, 24 equals 8x. And then divide by 8. 24 divided by 8 is 3. Okay, 3 equals x. Could you plug it back in and get the missing sides? Yes. Make sure you got that down. Flip it over. We're going to do 4 on the back here, okay? Some of these on the back are tough, so I just got to make sure I show you. Stick with me, please. All right. Here we go. On the back, number 8. Now, do you see how there's no picture? This is the hardest one. Please focus on this one, please, okay? Number 8, there's no picture. It would help you to draw one, right? So go ahead and draw yourself like an isosceles triangle here. Call it RTS, RST, whatever, okay? It tells you something. Right here, look. RT is congruent to ST. So go and put a tick mark at RT and a tick mark at ST. Okay? Now, we've already said this, but if you have 2 equal sides, that's going to give you 2 equal angles, right? So this means angle S and angle R are congruent. Okay? Okay, so here's the deal. I draw a picture, I know the sides are equal, so that means that the angles are equal. Now I can set R and S equal, right? Hey, so I don't care about T. Only R and S are equal. Only these are equal. I don't care about this right now. I don't need T in my life right now, okay? So I'm gonna set R equal to S because they're across from the equal sides, okay? So measure of angle R equals measure of angle S. Plug it in. So R is 9x plus 2. S is 13x minus 18. X is on both sides, so I need to get rid of the smaller x. Minus 9x, minus 9x. Bring down 2. 13 minus 9 is 4. Get rid of the loner minus 18 by adding 18. 20 equals 4x. And then you divide by the coefficient to get 20 divided by 4 is 5. Once you have x, could you plug it back into every single angle and find the missing angles? Okay, I know that's monotonous, but you plug it in here, plug it in here, plug it in here. Replace it with 5. So for angle R, 9 times 5 plus 2 is 47. Angle S is 13 times 5 minus 18, which gives you 47. And that should make sense, right? Didn't we already say R and S are congruent? And then angle T is 17 times 5 plus 1, which should be 86. Okay, make sure you got that down. And you plug them all back in to get that. Still got 3 more to do on this page. Okay, number 9. Same thing, draw a picture. DEF. So D, E, F. D and E are already congruent, like it says right here. So good. This is a converse problem. If you know that angles are congruent, you go across. That means the side lengths are congruent. That's DF and EF. Okay. So if DF and EF are the same, then I don't care about DE for now. Okay. No DE. You don't scratch it out. I'm just saying, like, I don't care about DE at this point in time. I'm going to set DF equal to EF. So I'm going to have 7x minus 35 equal 4x minus 8. And just like the last three problems, you're going to solve it. You get rid of the smaller x, get rid of the loner, and divide. So the smaller x is 4x, so minus 4x. 3x, bring down minus 35 equals negative 8. Get rid of the loner, add 35. 3x equals 27. Divide by 3. X equals 9. And once again, once you get x, can you plug it back in to every single segment? Here, here, and here. So for DE, it's going to be 9 plus 4, which is 13. EF, which is going to be 4 times 9 minus 8, 28. And that EF is supposed to equal this DF. So 7 times 9 minus 35. 63 minus 35 is 28. Whatever those units are. Make sure you have this down, number 9. Okay, make sure you have it down. The back, everybody, make sure you got this down. You can slash through 10 because we're gonna not overkill this. And then on that bottom half, we're gonna do 2 problems out of those 3, and we'll be done. Okay. I know this was a lot, but it's simple theorems, but the applications are kind of wide. So does anyone still need number 9? Okay. Give you a couple seconds, get number 9, and we're going to do the next one, equilateral triangles. Y'all ready? Equilateral triangles. Here's the deal. Let's do this fast. Get it over with, right? So stay with me. What do we know about equilateral? All the sides are equal. Go ahead and put tick marks. Tick, tick, tick. But this says it's equilateral if it's equiangular, right? So that means all the angles would also be the same. So here's how you write it. If A and B and C are equal, then AB equals BC equals AC. And if all those sides are equal, then that means all the measurements of the angles are also going to be equal. All right, so this is pretty straightforward. And then write this down. The angle is always equal to 60 degrees. For equilateral, if you divide 180 by 3 equally, you will always get 60, okay? So for equilateral, the sides are all equal, the angles are all equal, And the angles are always 60 for an equilateral. Very important, okay? So we're going to do 11 and 12 and call it a day. Number 11, if I see two 60s, what is this third one going to be? 60, because it adds up to 180, right? So now I see that it's equiangular. Well, that means it's also going to be equilateral. So if I see three 60s, then that means all the sides are the same. If one side is 9, what are the other two sides? 9, 9, right? So now we can answer these questions really easy. What's angle C going to be? 60. What about BC? What's that side length? On the outside. What's BC? 9. What about AC? 9. All right. Easy, right? If you know it's equilateral, everything's the same. All the angles are 60. Now, number 12. Is 12 equilateral? Tick, tick, tick. Yeah. So all the sides are what? They're equal. If one of them's 24, what are the other two? 24, 24. But I don't need to know that. It's asking me about the angles. Now, even though I don't have any angles labeled, equilateral means equiangular, and equiangular means 60, 60, 60, right? For sure. So that's it, 60, 60, 60. Do y'all need me to show you another example of this stuff, or do you know that you set equal things equal and solve, right? The one thing on number 13 that I will say, here's a little tip. If you have an angle in an equilateral, set it equal to 60 and solve, okay? That's my one little tip. Because when you get to number 8 on the assignment, and you have an equilateral, you set that angle equal to 60, and then you solve, okay? I'm going to pass out the assignment early, but we're working on this tomorrow too, okay? Does everyone understand? The extra credit is not your assignment. That's extra when you finish things, okay? Here we go.